All right, today we're going to jump into a really fascinating new way of thinking about artificial intelligence. We're looking at a no-code platform from the HumAIne project, and it's designed to teach AI not just to see patterns, but to actually reason, kind of like a person does. This whole thing is about bridging the gap between just recognizing stuff and truly understanding it. So let's see how it works.
So to really get what makes this so different, let's start with a question. Think about how you think for a second. Sometimes you just have a gut feeling, right? A quick intuition. Other times you got to slow down, think through the steps, and use some logic. So what if we could build an AI that does both of those things?
This whole idea of two ways of thinking isn't new. It actually comes from the psychologist Daniel Kahneman. He talked about two systems. System 1 is our fast, automatic, intuitive brain, which is a great way to think about how standard neural networks just chew through massive amounts of data. And then you have System 2. That's our slow, conscious, deliberate mind that uses rules and logic. And that model is the inspiration for this new, much more powerful kind of AI.
And that brings us to the official name for it, Neuro-Symbolic AI. It's a field that's all about creating these composite AIs that merge the best of both worlds. So you get the incredible pattern-spotting abilities of machine learning, our System 1, and you combine it with the structured, logical reasoning of symbolic systems, our System 2. The big goal here is to build AI that isn't just powerful, but is also way more robust. And, this is the key, more trustworthy. That's absolutely essential in fields like medicine or finance, where because the computer said so just doesn't cut it.
Okay, so here's our game plan. We'll start with the core tech that makes this thinking twice even possible. Then we're going to walk through the super simple, no-code workflow that puts all this power into the hands of actual experts. We'll see how you can train an AI with plain English rules, and finally, take a look at how the AI explains its own thinking.
Let's dive right in with how this whole thing actually works under the hood. How do you really get a machine learning model to understand and use logic?
Well, the secret sauce, the engine that makes this fusion of logic and learning happen, is a technology called Logic Tensor Networks, or LTNs for short. This is the absolute key to the whole puzzle.
And check this out, because this diagram shows it perfectly. On the left, you've got your data features, and they're feeding into a pretty standard neural network. But now, look at the bottom. We have these human-readable rules. Stuff a doctor might know. These rules aren't just checked at the end. Instead, they create what's called a constraint loss. Now, in machine learning, loss is basically a penalty for being wrong. So here, the AI gets penalized during its training if its predictions break these expert rules. This gives direct training feedback, basically forcing the network to learn in a way that lines up with that baked-in human expertise. It's brilliant.
Now, I know that all sounds pretty technical, right? But the whole point of the HumAIne platform is to make this stuff accessible to everybody, not just AI researchers with PhDs. So let's see how they turn this into a really simple workflow. The platform walks you through this super clear 4-step process. It's just laid out in 4 simple tabs. You load your data, you define your logical building blocks, you train the model with your rules, and then you get explanations for what it did. It's a complete journey from start to finish.
Okay, first up, loading your data. What's awesome here is just how flexible it is. You're not stuck with just spreadsheets. You can upload your tabular data from CSVs, you can use zip files of images or even text datasets. And you can see it also hooks up to cloud storage like Minio. This just means it can tackle a huge variety of real-world problems, pulling in data from wherever you keep it.
All right, the next step is where the logic really starts to come in. You define predicates. Now that might sound like a complicated word, but it's not. A predicate is just a simple, named condition based on your data. Honestly, think of them like the Lego blocks you're about to use to build your expert rules.
And here's a perfect example from a breast cancer data set they used in the demo. You take the data column called clump thickness, you give it a nice clear name like high_clump_thickness, and then you define the logic. The value in that column has to be greater than 4.1. And that's it. You've just created a logical building block that the AI can totally understand.
So we have our data, we have our logical Lego blocks. Now for the really exciting part, using them to train a much, much smarter AI model.
Look at this. This is a real rule, written in plain English that was used in the platform's demo. Just notice the language. A doctor, a domain expert, anyone could write this. There's no complex code, no weird syntax. You're just taking your knowledge and writing it down in a natural way using those predicates you just made.
And here's the magic trick. Behind the scenes, the platform uses a large language model to take that simple English sentence and translate it into the formal, structured logic that the Logic Tensor Network needs to do its job. This is the key that makes the whole interface so incredibly powerful for people who aren't coders.
So,
The million-dollar question is, does it actually work? Well, this table says it all. On the left, you've got a standard machine learning model, an MLP, trained with 0 rules. On the right, our logic tensor network, trained with those expert rules. You can see a clear jump in both accuracy and the F1 score, which is a metric that gives us a really solid picture of the model's performance. The proof is right there. Now, getting a better prediction is great, but in high-stakes areas like healthcare, you need more than just an answer from a machine. You need to know why. And this brings us to the final and maybe the most important part of this whole thing, building trust.
This is the absolute core value of what we call explainable AI, or XAI. We're finally getting away from the black box, where you feed data in, you get an answer out, but you have no idea what happened in the middle. This platform is designed specifically to crack that box open and show you the reasoning behind its conclusions. That's how you build trust and accountability.
And the explanation you get is incredibly rich. You don't just see the prediction scores. You get a SHOP plot. And SHOP is just a powerful way to see exactly which data features push the decision one way or the other. You see the impact of every variable. And crucially, it shows you exactly which of your expert rules were triggered for that specific case. And then it wraps it all up for you in a plain English summary.
This architecture diagram really pulls everything together, doesn't it? You can see the non-technical user over on the left providing their domain knowledge through that simple UI. That knowledge gets translated and used to train the model. And on the right, you still have the ML engineer who can go in and fine-tune things. It's a truly collaborative system designed for building AI that we can actually understand and trust.
So all of this brings us to one final thought. By combining the raw pattern-matching horsepower of neural networks with the transparent, auditable logic of human expertise, are we actually looking at the future of trustworthy AI? It is a super compelling approach, one that finally bridges the gap between what a machine can learn on its own and what a human expert already knows to be true.